I don't think I need the internet. Oh, I'm currently live on air in English, maybe just for this one class, but still. Just want to tell people on YouTube what they need to know. That's fine. Oh, don't put out of memory. Oh, no, I don't want to exit. No. Okay, fine. Let's just see. English, Afrikaans, English, Afrikaans, English, Afrikaans, English, Afrikaans, English, Afrikaans. Ooh! Okay, but since the translators are not here, and never were, the interpreters are not here, and that's on home, I'm going to stick to English, at least just for today. I'll pay you back by having an Afrikaans lecture in the next week. Okie dokie, where are we? Did you have recess? What do you mean no? What did you do? Did you come? Did you guys really show up here while I wasn't here? Well, I didn't have a recess. I had a research recess. Part of my job, and all the teachers should have in computer science, is that we also have to do research. Because that's good for the university, and that's how we get money. One of the ways. It's important because university is really about making knowledge in two ways. Teaching people, so spreading knowledge and stuff like that, and also creating new knowledge. Researching ways of doing things and all that. And consequently, I am really behind on this course. I didn't think about you a second. So even though I was supposed to, I didn't upload any marks. I haven't fixed anything. I must get all of that done today, because otherwise I'm really going to be behind, and you're not going to like it. What do we still have to do? Well, this week I'll talk about recursion, and similarly for next week. So 2 weeks of recursion. We've done all the basic stuff. We've really covered all of Java that you are going to learn in this course. There might be a few things we haven't talked about. One big thing is objects, and Java's object-oriented. We'll do that next semester. You really know all the Java you will know in this course. You want to ask me something? Oh. Where are the class representatives? Benny and Danielle. It's not quite here. Benny, there is a meeting for class representatives on Wednesday. Do you know about it? Have you received an email? Okay. So I'm telling you now, there's going to be a meeting at 1 o'clock on Thursday. Wednesday. So, Wednesday, 1 o'clock. Here we go. This day, 1 o'clock, and you must please be there. If you have complaints or compliments or things that you want to have changed about the course, please speak to Benny. Don't speak to me. I'll probably be there, but Benny will give you feedback. Don't be ashamed or embarrassed or shy in any way. That's what the whole system is for, to get your feedback. So Benny, I'll send you an email. You probably get another email from the person who is managing that. Okay, I'm behind on admin. There's a meeting that you can complain about that if you want. This schedule is going to change a little, and I'll fix it today on the website. But this is tutorial 7 on Thursday, which you'll have, which will be about recursion. A little, because we wouldn't have that much of it, but it will still be all about recursion. This tutorial will not happen, because bad news, this practical test will move 1 week out. And I'll trade you something in return. I'll trade you something valuable. So, tutorial 8 will not happen, but practical test 2 will happen in tutorial 8's time slot. Okay? And then the next time you're writing a test, sad news, but that's not what I'm trying. We can't have this practical test on Thursday, the 30th of April, because this Thursday is a Friday. The government has announced that they're changing the calendar around to switch Thursdays and Fridays. I don't know if you know about this. It's a big thing. And I cannot believe that there are people who would believe something like that. I hope that one thing you learn in the course, I try my best to lie to you as much as possible. I hope that you learn to detect lies. Perhaps we should do a little test on that soon. Perhaps even today. You must be able to detect lies. Some people are going to fake you out. Okay? They are going to lie to you. You must learn to detect them. The university is following the Friday schedule on this Thursday, which means if I say there's a practical test, people will complain that they can't go to the Friday tutorial as they're supposed to, and that the studying is messed up. Good news is that we have a class on this Friday morning at 8 o'clock, which made me think that we should have our class on the Wednesday as well. But what I'll trade you is that we have no class on Friday. So this whole week you won't see me, which must be worth something. Moves 1 week ahead, but you're getting one fewer tutorial and 1 week fewer of the CV. Okay. This is Wednesday. Just to be clear, I know people don't, students only hear 10% of what you're saying, and they only remember 10% of that. But the government is not switching around Thursday and Friday. I wonder if we should have a little test. Do we need a little test in class? Kind of poppy quizzy thing. It'll be quickish, and I'm lazy, and I'm still want to be on my research recess. So let's see if I can give you a little test. Yes, you like it. Don't tell me I've deleted it. I've got a new PC at home, and I've moved a lot of stuff around. Thank heavens. Okay. So I want you to take out a piece of paper. Now, piece of paper. And also a pen. Okay. This is university pen. You don't have to move around. No chatting. No noise. No cell phones. Okay. No studying material. Don't look it up. It's not letting go. Put numbers 1 to 10 on your test. 1 to 10. Sorry, 1 to 20. 1 to 20. Okay, that's easy. Okay. 1 to 20. I'm going to show you a short video, and you must tell, there'll be a person in the video who is smiling. There'll be a smiling person in the video. I'm just going to show you a 5-second video of someone who's smiling. In fact, I'm going to show you 20 of those videos. And for each one, you must put down genuine or fake. Fake or genuine? Okie dokie. It's going to be really quick, and I'm not going to show them the second time. So I'll just be going through them pretty quickly, so you have to watch out. Okay, are you ready? Smile 1. Okay. Smile number 2. Genuine or fake? Just write G or F. Smile 3. Smile 4. Smile 5. Smile 6. Smile 7. Genuine or fake? Smile 8. Smile 9. No cell phones in the test. Smile 9. Smile 10. Smile 11. Smile 12. It's calling you. Tell your mother that you're busy. Smile 13. Smile 14. Smile 15. Smile 16. $17. 18. 19. And number 20. Okay, right. And now you're going to mark your own tests. Okay, I'm going to, just to make it easier for you, I'm going to read out the answers out loud. I mean, not a secret, but I'll just read them just to be efficient. So, genuine, fake, 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 genuine, genuine, fake, genuine, fake, genuine, genuine, fake, fake, fake. Number 15 was genuine, 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 fake, genuine, fake. Okay, and now the important part of the test. Who scored 5 or lower? Fewer than 5 correct. There's no shame. 10 or fewer correct. A little shame. 15 or fewer. I guess most of you. Okay. 16 or not or fewer. It's only 16. Okay. 17. Oh, okay. 18. Okay. 19. Okay, so 19 and 20 is really psychopath level. Watch out for those people. They're probably going to kill you. Just say 20, only 20. Don't be ashamed. Don't be shy. Why 20? Okay. I'll do 20. Right. Every year there's at least 1 or 2 20s. Correlates with the number of serial killers in the population. Okay, fine. Good. So I'm glad I started my test. Right. Let's just quickly go back here. So, this week, next week, recursion. Then a week, you don't see any. At the end of next week, not this week, but next week, we'll have practical test and a written test. The week after that, we're going to talk about this topic, universality and computability. Project demos are here. if you have a medical certificate for practical tests, then you are allowed, or demo, you are allowed to do a makeup here, but not for the written tests. You don't get any makeup for the written tests because there are 3 written tests, of which only 2 count. So only the highest 2 marks are counted. You have 1 freebie. And if you were ill on all 3 dates, that's suspicious. If you were ill on 2 of the dates, I'm sad. So if you're only ill on 1 date, then that's a little sad because you don't have the lowest mark. That'll be the lowest mark on that score. But you have a freebie, so you can actually be ill on 1 of the days. But of course, you all come and write the 3rd test because you want to improve your score as much as possible, especially seeing your low scores are. Okay, right. So project demo, university, and the last week we'll do revision. And then there's the final exam down here somewhere that unfortunately you have to write. The university insists that we make use of the exam time. And in previous years, I've always said, oh, we'll just let it count 0. So if you want, you can write the exam, but know that it will count 0. This exam will not count 0. You have to write it, okay? It will count for your mark. I don't know how much it counts, but it will count for your mark. Don't not come to the final exam. This is fascinating stuff, and it's really interesting, and it's really sciencey. And I strongly urge you to come to these lectures because this stuff is really core computer science. If you are going to get one of computer science, even if you're not, this is the kind of stuff you should know. Of course, I think you should know everything, but this is the kind of stuff you want to know. But this week I'm actually talking about recursion, which is a really important technique in computer science. What is recursion? Let's do these slides. I think I'm only going to do like 5 slides today, and if I finish, I finish. What is recursion? It's when one function calls itself. That's not the full extent of it, exactly. We've been writing functions, only one function, in fact, main, for the longest time. And then a few weeks ago, we discovered that we can write our own functions. We can implement our own version of sine or cosine or anything else we want. If you had a thought about that, I hope you're pretty happy about it. We can write functions, and we can call those functions, and they can call other functions. So we can have this recursive stack of functions calling each other. What we haven't done until now, I mean, you could have done it, but I tried to avoid it carefully, is having one function that calls itself, which sounds a little odd, but we are kind of used to it. We've seen this kind of thing before. Well, we'll see examples soon. This is a drawing by MC Escher. If you don't know his art, it's really good. It's really interesting stuff. He's got this, I don't think it's called redundant parts. I think this drawing is called hands drawing or something like that. But it's one hand drawing, another hand draws, and third hand. In fact, a lot of his stuff is like this. I'll just waste time and show you some more of Escher's stuff. Because it's really fascinating, and you should know. An educated person should know what Escher drew. Just give me a second. I need to find my password because I changed it last night and I can't recall the new password. Stellenbosch. See, it's long. I can't recall it. Yeah. Here we go. MC Escher. Okay, and we'll just go to images. Oh, I saw a movie. I don't often watch movies. I don't know. I just listen to the radio. Did anybody see Night at the Museum 3? 4? Or something? Did you see this again? Did you see this part of it? Was it this one? I don't think this is the one. This is it. Relativity. So there was a painting. This painting was exhibited somewhere in the museum, and actually went into it and had all this crazy gravity and that. But Escher made a couple like these. That's this kind of thing. I'm not going to show you the others. It's the same one. This is another famous Escher. Let's just see if we can find it a little bigger. No, we can't. So this is all pencil drawing. In fact, I think this is a pencil. This may be lithograph, but never mind. So let's pretend it's pencil. So this is a pencil drawing that the artist made, where he's holding up this crystal ball, and you can see himself reflected in it. All the geometry is perfect. And not exactly recursion, but recursion in some kind of way. We are seeing what he sees, which is what he sees, which is what he sees, which is what he sees. So that's recursive in some sense. It describes itself in terms of itself. Let's see, all this stuff is wonderful, but I just want to find the recursive one. So I guess this is kind of recursive. Angels and demons. No, it's not angels and demons. The waterfall is beautiful, but it's kind of recursive. Well, let's see. What's this about? Okay, so this is not recursion. I would say that this is more of an illustration of background and foreground, which is something he did a lot. In the sense that if you look up here, the little demon, ogre, it's not exactly a demon, and the man are fit perfectly. So their postures fit perfectly. If you only look at the black, you can see the ogre. If you look at the white, you see the man. So that's not exactly recursion, but I'm sure I can find one. Hang on. This is recursion. Yeah, I don't know. This is not a perfect illustration of recursion. It's perhaps more background, foreground. But this is the kind of stuff that Escher drew. Okay. So that's one of his hand on your hand. It's beautiful. Recursion is a special way of thinking. When you want to write a recursive function, you have to be kind of careful at first because you have to think in a certain way. At first it's difficult, and the stuff we do will be kind of easy, but later on in the second semester you'll do recursion where it's really mind-boggling. Most people have a problem with the idea that I don't have to write this function, I can just call it and it'll do what it's supposed to do. So that's kind of tricky at first, but never mind that. Where do we use it? It's used all over the place, including sorting. So we have a lot of numbers, we want to sort them in some kind of order, and we can do that recursively. If you think about it, this thing called merge sort is almost how I sort your test papers, your answer sheets. And that is that if I want to sort all 180 answer sheets, I divide them into two piles, and I sort the two piles, and then I just merge them. So I take the least, put it on the new heap, take the least top one now, put it on the heap, until I've merged the two piles together. But I haven't told you how I sort the individual piles. And how I do that is I take the first file on the left, half of the question papers, 90 now. I divide it into two piles, I sort both of those files, and then I merge them together. And how did I sort half those half piles, those 45 papers? I divide them into two piles, almost exactly 22, 23. I sort them, and I merge them together. So this process repeats itself. I sort, I explain to you how I sort, but in the process I'm saying that I sort as well. So it sounds like a circular argument. And that is one of the pitfalls. You have to be careful so that you don't land up in an infinite loop where you call yourself all the time. You have to stop it at some point. So let's look at a little example. GCD. I think we actually have an exercise about this, about Euclidean algorithm for calculating the GCD, the greatest common divisor. Let's just have a little look here on the web. Tutorials. Oh man, why isn't that loading? Is this going to load? Oh, okay. Fine, it did. Okay, so this tutorial where I gave you an algorithm for calculating the GCD. And this algorithm was of the while loop. And there's nothing recursive about it. And all I ask you is to implement it in Java. And that's easy peasy because you can just write it down in Java code and you can test it with these numbers. So if you did that, let's see if we can find a solution. Too easy, I agree. But what I ask you to do is to implement it as a function. So here's stuff that handles all the command line arguments that finally it invokes, calls GCD of A and B. And then to call this little function, and the code was really essentially exactly as it was on the web page. So it sent back the A which answered the GCD. But that is Euclid's algorithm, but Euclid's algorithm recursively. I didn't tell you that. Usually, we have this definition of Euclid's algorithm, which says that if you want to calculate the GCD of P and Q, and Q is 0, then the GCD is just P. So the greatest common divisor, the number that is largest, that goes into at least once into P and into 0 is P. Which doesn't make sense exactly because of that goes into 0. This is part of the definition, we just have to believe it does work out. But if you have anything else, if you have anything except a 0 for Q, we say that the GCD of P and Q is the GCD of Q and P mod Q. So I'm defining the GCD function in terms of itself. It calls itself again. And it's going to call itself again and again and again and again. Okay. So, I wonder if I can break this. Maybe not. Okay. So, we can implement this in Java. Let's start to do that. Let's just see what happens. Here we go. Close all this stuff. Close all. In here, I want a new project, which I call GCD. And inside GCD, don't break. In here, I want a package that I call GCD. And I want a file called GCD. Okay, fine, great. And I want a main function, so I'll type main control space. I work on research, and in one project, working with people at NASA in California. And they use a system called Mercurial, which means I have to install Mercurial on my computer. Remember, Hg is the chemical symbol for mercury. So there's a little plugin called Mercurial that's running in this Eclipse, but it's so stupid because it's always hanging like this. So I still have to remove that, which is why it's so slow. Okay, there's my main function. And I can check the command line arguments, but for now, I'll just assume that they're correct. So I'm just going to say the first argument is integer.parseInt arg0. There we go. Oops. And the second argument B is the same thing. And then I'm going to print GCD of A, comma B is equal to GCD of A. And Java complains that I haven't defined GCD, so I'm going to define it public, private, static. It's going to send back an int GCD, takes int A and int B. Now Eclipse is complaining that GCD promised to send back an integer, int, but it's not doing that. So I have to add that code. I could just add the code from the tutorial. I mean, if I were to take this code and dump it into that routine, I hope that it'll work. But I'm going to take my new definition. So let me just get my new definition. It's P if Q is 0. So in this case, well, let's rename these. Let's call that Q and that P. If Q is 0, then the GCD is just P. Otherwise, it's the GCD of Q and P mod Q. Okay? Otherwise, I'm going to send back the GCD of Q and P mod. That's right? Q and P mod Q. Okay, so Eclipse stopped complaining because I am returning an integer now. I've just taken the definition that I found on that slide, and I've really just typed into the paper. I still don't quite understand how and why this works. I'm not sure it will work. I mean, that definition might have been wrong. I might have made a mistake when I typed it. But we can definitely see that it's some kind of recursion because we have a function called GCD, and it's calling itself. To compute the answer, to compute the GCD, it's using itself to compute the GCD of two other numbers. So it doesn't feel quite right, but that's the definition. Let's just see if it works. Save everything, and oh no, how long do we have to wait for this? No, quit that. I don't want to do that. Quit it. Quit that as well. Oh, now it doesn't even want to. Oh, hang on. Can I do this in the background? No, I can't even do it in the background. Perhaps I can stop that as well. Stop. Stop. Oh, good. Let's just switch back over to text. I'll promise to fix my Eclipse next time we meet. Let's go back here, because at least here I know that I can use my compiler and it'll work perfectly. That's a bummer. Are we still online? Hang on. Yes, excellent. YouTube is still here. Good. So I'm going to go to my RW114. I'm going to edit gcd.java. Okay, I'm going to take out the package. We started adding the package when we used Eclipse, but for my command line programs, I'm not using it. Okay, compile. Does it work? It's going to take a little while. Running the Java compiler. Remember, this also has to do that. There we go. Now, I want to test it. What numbers do I test it with? Well, I'll start off with a few I know. So I know that 2 and 3 are relatively prime, so I expect their GCD to be 1. Largest number that divides both 2 and 3 are 1. Okay, good. 2 and 5 are also relatively prime, so the largest number that divides them is 1. Good. 2 and 4, I know that 2 goes into 2 and 2 goes into 4, so I expected 4. Excellent. So it seems to work for a few examples that I try. Let's just see what it said on the web. Firefox. Oh. Web. It said we should try -1 and 80. Well, that was because the exercise asked you to also check the parameters. I haven't even that far. So I'm not going to try that. Or maybe we should, just to see what happens. But we do it later in case it explodes. Okay? 15 and 5. Okay, I can do that. 15 and 5. 5, good. 5 and 15. Ah, it's trying to trick me. I'll just leave that. 99 and 88. 11, good. 3 wati wati and 1 2 wati wati. 9. Oh yeah, 9. Okay. Next one. So it seems to work for all the examples, except the one where checking was involved. Let's just see what happens. Because we're adventurous, we're not afraid that the computer will break or anything. Let's just try these. 5 and 15. Will this new GCD be able to handle it? Aha. Okay, that didn't go too badly. But let's see what happens with -1 and 80. What's the answer? What is the answer? What is the largest number that goes to both 1, -1, and 80? I would say 1. Because 1 goes into -1, kind of by definition, and 1 goes into 80 for sure. And I can't think of a larger number than 1 that goes into both. So I want 1, okay? But I get -1. Oh, that's too bad. I wonder why that is. I don't like not knowing something. I want to know exactly what the computer is doing. I mean, this is a mystery because why does it get -5? Is it simply because the recursion is broken? It doesn't work as before? Or is GCD not defined for negative numbers? Or is it something else? Something just quirky about this implementation? We'll find out. Let's just see how this works. So, every time we call GCD recursion, it is broken the problem of finding the greatest common denominator into a smaller problem. You ask me to multiply 50 and 20. I can't do that. But I can multiply 5 and 2. So I've broken your problem into something that's simple. I can multiply 5, and I can multiply 2, and I know it's 10. And I know the little numbers were 10 times and 10 times larger. So I multiply my answer 10 by 100, and I get 12. So that's how I know that 50 and 20 multiplied together is 1000. Let's find the divisor. What's your name? Yes. What? Shuaib. What is that? AIB. Shuaib. What's your name? Shuaib. What is 18 times 45? What? I can't do it. Come on, it's so easy. What's 3 times 5? Okay? And 9 times 2, and 9 times 5. So 18 times 45. 9 times your answer is 10. Which is 9. Is that correct? Why does it work? I mean, it works for 20 and 50. 2 times 10, 2 zeros, and together, so 1000. But now it seems broken. Don't get a calculator. Right? What happened? I had 2 times 9 and 2 times 5, and I got 10. You multiply with 5, and I multiply by 9, I get 90. But 18 and 45, it's not multiple to 90. 2 times 45 also. Okay? Any solutions? I just picture a model. Okay, so there were two lines. We have to multiply the first line and the second line. It's 81. 81 times 0 answer. Okay, anybody else get 810 on the phone? Excellent. So nothing is broken, it's still working, we start there. But the idea was to illustrate I can take one problem and break it into smaller parts and use that smaller parts to get the original answer. And that's what's happening with GCD. It's taking the P and Q and making them smaller. So how do we know that this is smaller than that? It's another big question. Does it help you if I say it's a big question? How do I know that these two numbers, Q and P mod Q, is smaller than P and Q? Come on, what's your friend say? Because you keep on looking at him. Are you doing the real one? Or you just learn it fast? If you ask me, don't be afraid to do what friends are. It's my turn. Because you just find what are you going to do with it? I'm just saying, if you have a BA in psychology, you can't find employment with that. I mean, you can leave, you go to all great places like a garage. And there's nothing wrong with that kind of employment. It's just that for psychology specifically, you need at least a master's to practice on psychology. So what are you going to do from that model? Study. What is it? Right. Awesome. What is it from? Yeah, are you into it? Okay, David. Right. How do we know these numbers are smaller? And God say, don't you start looking at the first thing. Go down the line. Well, hang on. Firstly, is this smaller, this P mod Q? Is that smaller than Q? Why? Yeah. Why? Come on, I need anybody to get this one. Are you Adam? Oh, excellent. There's nothing to Jewish person. Adam is also Jewish. Oh. Adam, why is it smaller? Why? Okay, excellent. That's all you needed to say. Just remind me. I'm asking for the remainder of things dividing P by Q. So it's probably bigger than Q. Otherwise, I could have divided one more time. So this remainder will definitely be smaller than Q. So we know that this number is smaller than that. But now here's the trick, David. How do we know that Q is smaller than P? And I'll give you the same time as you show up. Right. I tried to answer that what your mother could call you. Shuaib. It sounds a little doo-wop. Like it's something in a song, Shuaib. Adam, you're going to say, I'll give you the same clue. A big question. What? No, 100 for us. You lied. You lied, Adam. It's nowhere. It's nowhere. It wasn't, we weren't told. I know in the exam, in the tutorial, there was a question, but it's not applicable. It's a trick question, so the answer must be that we don't know that it's smaller. Initially, that P can be smaller than the Q. So what we're putting in here is a smaller number than Q, sorry, a larger number than Q. P can be smaller. But the time after that, we know that this number, this one, will be smaller. So this Q will be smaller than P. Because that's Q, I'm saying over the Q, and something mod Q. So it will be something, a Q, and something that's mod the remainder of the dividing by Q. This will definitely be smaller than Q. So the very first time, we don't know that we are reducing the formula, but the time after that, we're definitely reducing it. Now, there's an illustration of why this works. There's this beautiful picture that explains why and how this GCD thing works. But I can tell you honestly, I don't get this thing. I understand what it says, but I don't feel it in my gut. I don't really understand. I can't intuitively. I was made this up if I had to explain it to someone. But here's the bottom line. There's our P. It's a very big number. Let's pretend for now P is 1 Q. It's a big number. Here's our Q. The GCD of P and Q may not be Q because Q may not go even number of times into P. For example, here I show that Q goes into P once, twice, 2 times only, and this piece is remaining. Is P mod Q. It's the remainder that's still left over. And in actual fact, the GCD of P and Q is this X. Because X goes 3 times into Q, 3 times into that Q, of course, and then twice into the remainder. And what we're doing now is we're asked to calculate the GCD of P and Q, and then the function calls itself, and it tries to calculate the GCD of Q and P mod Q. So it's taking this piece and putting it down here and saying, here are 2 numbers, calculate their number. And then what will remain is X, and in the next term, the mod will be 0. I'll try to explain this a little better next time, but I'm going to stop now. You're fidgeting a little too much. So I'll see you on Wednesday. Penny, very important, Penny report to reception. Penny. Accident in this one.